Hi everyone, my name is Youssef Saleh and today I'm going to be solving with you a topic 3 paper 2 question, and this is the exam code right here. Okay, to be able to solve this question, you need to have a periodic table beside you, and you will be given this in the paper 2 exam with the data booklet. The context we're given for the question says that a periodic table shows many patterns and periodic properties. And this is the format of the element box in this question. X is the element, Z is the atomic number, and A is the atomic mass. And this will be the format in most of the periodic tables. So for the first part of question number 6, we're asked to identify the property in which the elements of the periodic table are arranged with. So looking at the periodic table, we have multiple observations. So we know that each element has a different relative atomic mass than the other, and we can see this right here. We can also see that each element has a different atomic number than the element next to it or under it, but we can see that in each period, going across the period, for example, from potassium to krypton, we can see that each element has the atomic number increased by 1. That means that the protons and electrons are increasing by 1 each in the element. So we can say that the property in which the elements are arranged within the periodic table is the atomic number of the element, number of protons and electrons in the element. Now, for the second part of the question, part B, also part B has two parts, or it's divided into two parts. So the first part, part I, is asking us to define the term electronegativity. Remember that defining terms are basically your 3 points in the exam. So what does electronegativity mean? Electronegativity is the ability of an atom or element to attract electrons in a chemical bond. So, first of all, you get a point for writing all of this and writing electrons with an S. It needs to be plural. If you write one electron, or if you just write electron, you won't get the point. And writing in a chemical bond or in a covalent bond will give you the second point. And the number of marks are written here on the side. So, electronegativity, as we said before, is the ability of an atom or element to attract electrons in a chemical bond. Electronegativity also increases from left to right. And what does that mean? It means basically that the electronegativity increases because the effective nuclear charge is increasing. Increasing the effective nuclear charge means that the attraction between an atom's nucleus and its valence electrons increases. As a result, the elements will want to gain more electrons, or they have a higher or larger ability to attract more electrons. So, elements on the right side of the periodic table have a higher ability of attracting electrons. They have a higher electronegativity. For the second part of question B, II, we're asked to write two reasons of why the electronegativity increases on a periodic table from left to right across a period, and this is a type right here, it's supposed to be from left to right, and we're asked to write one reason for why the noble gases don't have electronegativity values. So to start answering our question, we said that the atomic number of elements increases across the periods from left to right on the periodic table. This means that the number of protons and electrons in an element increases. The protons are added to the nucleus and the electrons are added to the outer most energy level or outer shell. This also means that the energy levels between the nucleus and the outer shell are not affected, they stay the same. All the electrons in these levels are known as shielding electrons. So the shielding electrons stay constant across the period from left to right. This means that since the number of protons is increasing, but the number of shielding electrons stays the same, the effective nuclear charge increases, which means that the atom has more attraction between the nucleus and the electrons in the valence shell, meaning that the atom's size or radius will decrease, will decrease, and the atom will have a larger ability to attract more electrons in a chemical bond. So atoms on the right have a higher electronegativity. Now, and here you get 2 marks for writing all of this, and you need to specify your answer and write why this happens. Now, for the 3rd mark and the final mark, we need to write why the noble gases don't have electronegativity values. So we said before that all the elements want to have the same electron configuration as the noble gases because they are the most stable elements. So because the noble gases are already stable and they have full valence or outer shells, have full valence electrons in their outer shells, the noble gases don't want to attract more electrons because they already have full outer or valence shells. In other words, we can write that noble gases are inert. However, you can't just stop without saying that noble gases don't want to attract more electrons. They don't have that ability. So you need to continue on after saying that they're inert and write what's before it. For the final part of our question, part C, we're only going to be solving I. So it asks us for 2 reasons for why a sodium ion has a smaller radius than a normal sodium atom. So how do we find out what the sodium ion is going to be? So let's go to the periodic table. Sodium is in period 3, group 1. It has 11 electrons and it has 3 energy levels because it's in period 3. Sodium will want to lose 1 electron to become like neon. It wants to have 10 electrons. And neon is in period 2, so it means it has 2 energy levels. So if sodium loses 1 electron, it will go from having 3 energy levels to 2 energy levels. First of all, so sodium, Na, its ion is going to be Na plus because it's losing 1 electron. So the first reason we're going to say that is because a sodium ion, which we are calling sodium plus, will have 2 energy levels and the normal sodium atom will have 3 energy levels. As a result, Na plus has a smaller radius. The second reason we're going to write is that Na plus has more protons than electrons. So it has 11 protons and 10 electrons. As a result, it has a greater effective nuclear charge because the effective nuclear charge subtracts the shielding electrons from the protons. As a result, since sodium ion has only 2 energy levels, it will have less shielding electrons. So it will have more effective nuclear charge, and the pull between the nucleus and the valence electrons will increase and it will be greater in the Na+. As a result, it will have less radius than normal sodium atom. And that's it, ladies and gentlemen. Thank you so much for watching.